This episode takes us farther into the Intrepid AI platform by working with custom nodes and running simulations. We will use a pre-built Python node that generates positions to send to the controller and actually move a simulated vehicle. Let me show you how easy it is to do so and test your capabilities dynamically. Let's get started. In this tutorial, I'm going to introduce the usage of custom nodes, and we are going to implement a behavior of a drone that will follow a trajectory that we are going to create using the visual tools of the Intrepid platform. Now, I prepared a node for this tutorial, which is called tutorial 2. So we just insert that. Now, if you look at this node, it will have inputs and outputs. As you can see, there is an agent ID that you can specify manually in case you want to assign an agent ID, a number, essentially, to your vehicle. But it can also be assigned directly by the simulator. I will show you how to do that. Other inputs of this node are the drone position, basically the equivalent of the GPS readings, a trajectory that we are going to create in a minute, and then something does nothing, in fact, it's just a test. And then in the output signature, we have, of course, the altitude, the yaw, and the velocities in the 3 axes. Okay. Now, what this node does is essentially, something very simple, which is receiving a trajectory and following it waypoint by waypoint. As we get closer to the current waypoint, below a certain threshold, this node will essentially move to the next waypoint, okay, until completing the trajectory that we create. Now, in order to control the vehicle, I decided to use a velocity controller. For the roboticists out there, they know what I'm talking about. You can control vehicles by position, by velocity, by yaw, pitch, roll, and in this particular case, I decided to go with a velocity controller. This is not the best controller you can have, of course. It's an off-the-shelf controller that we wrote and we provide for very simple mini drones or nano drones. But of course, you are free to use whatever controller you want, especially for custom projects where you probably have your own controller, or using PX4, it's pretty much doable. Now, what we need to do is, in fact, just connect these outputs to these inputs, and essentially we would be done. So what we are doing here, essentially, we have a node that has been built for you. We are going to explore how to actually build this node in another tutorial. And then we are passing the outputs calculated by this node to the controller. Now, another thing that you have to know when you want to control a vehicle is that you have to keep sending commands or control commands to the controller at a certain frequency. So we're going to use this concept that we explored already in tutorial 1, which is the concept of timer event. And essentially, usually people send data to a controller at a frequency of 10 Hertz. We're going to do the same, nothing fancy. We connect this here and we are pretty much done. So in this graph now, we are essentially telling the runtime to calculate frequency, to calculate altitude, yaw, Vx, Voi, Vz at a frequency of 10 Hertz and send that information to the velocity controller. Now it's time to plug in the inputs. As I said, we have the so-called agent ID. This is essentially an ID that is released by the simulator that counts how many vehicles you are simulating, and we can just pass that to the input of this node. Then we have a drone position, which is the equivalent of a GPS coordinate, so GPS local. We are going to connect this there. And finally, the trajectory node that we need to create. There is a special node for that. It's called map trajectory. You can also plug in positions or areas. In this case, we need a trajectory. Now the trajectory node is probably the one that requires most of the configuration, which you can do from the sidebar on the right and define your trajectory using simple maps. Now I am in Brussels, I'm gonna stay there. Let's go to Brussels, maybe the magnificent Grand Place. There it goes, and here we can create a trajectory. For example, we can go around here, maybe there, there, and there. When I'm done, I can finish, and I have my trajectory. Of course, I can also edit in case I made some mistakes, so I can adjust this trajectory as I need. Then I save. Now there is another thing that we need to do in each waypoint, which is defining the altitude. Of course, we don't want to stay at 0. We are driving a drone today, so we're gonna fly to 10 meters on the first waypoint. We're gonna stay around 10 meters on the second. Maybe we go a bit higher on the third waypoint, and finally we prepare to, let's say, land, or we go down to 5 meters on the fourth waypoint. When we are done, we can connect this trajectory node to the trajectory input and save our graph. Now, what happens is that I also want to print some user-friendly information, for example, the altitude. So I decided to have this other branch of the graph, which says print something. This is basically what happened already in tutorial 1. We want to connect the altitude, which is the thing that we want to print. As you can see, as per tutorial 1, we have this automatic conversion that is done for you by the platform, and therefore we have to define another timer, which is, for example, let's say 2 Hertz, and connect this there. So what's happening here is that we have 2 branches of the behavior. In one, we are going to print at a frequency of 2 Hertz the value of the altitude in a message on standard output, so that we can see by the logs where the drone is flying at, and therefore at another frequency we have the node that will calculate the distances from each waypoint and move one waypoint at a time until the end of the trajectory. We are pretty much done. That's it. So what we need to do now is just simulating this behavior. In order to simulate this behavior, of course, we need to also build what we call the world graph. So what is the world graph? Is something that I prepared for you. Is essentially the graph that allows you to describe the simulated world in which you want to execute this behavior. And in our particular case, we have just one drone. So we use the spawn drone node, and we assign the tutorial agent graph that we have just created. We can assign it. We have a bunch of graphs, of course, but in this case, we are assigning this behavior to this particular drone. You understand that if you want to spawn multiple drones, you can spawn indeed multiple drone nodes, and at the same time you can also spawn from a for loop or from other programming constructs that are much faster in case you want to spawn, for example, a very large number of drones or other vehicles. Once we are done with that, what remains is essentially add, as in the tutorial 1 explanation, we need to add the tutorial 2 world graph to our project, generate the token, so copy the token and move to the simulator. In order to simulate this behavior, in particular this behavior, we go to the simulator and we type Intrepid sim. I will explain later what this -- load does. In this particular case, we are running a Python, a custom node built in Python. More on that in the next tutorial. And then, of course, we paste the token, security token that we have just generated. Once we're done with that, we can launch the simulator. And we should see the drone flying, spawned at waypoint 1. And of course, progressing towards the trajectory. As you can see here in the terminal, we are printing this 15, which is in fact the altitude that this drone is flying at. And that's essentially the debug log node that we have added to the graph. But if we want to see what's going on in the simulator, we can also click on the drone. I just move to the next waypoint, and now we are going to altitude 5, which is, I guess, the third waypoint, if I'm not wrong, and keep moving towards the fourth waypoint. In the other waypoint, we're going up again, and you can see this from the debug logs as printed on terminal, but also inside the simulator, this little number here that is going towards 10 meters. That wraps up this tutorial. If you'd like to learn more about Intrepid AI, feel free to visit our Discord channel or the documentation site. Thank you so much for watching. We'll see you next time.